Hey everybody, Trey here. Welcome back to another forecast discussion. We are entering into an active sequence of severe weather that is expected to begin tomorrow, Thursday, September 21st, and really peak on Friday and Saturday, September 22nd and 23rd. We are definitely kicking off this fall season with a bang over a large area as well. It's not just a confined area of severe weather. We have multiple states, multiple regions under the gun for severe weather over the next few days. So, wanted to do a forecast discussion video where we go through a few different models and compare and contrast their solutions for especially Friday and Saturday, as that appears to be the main show, and that's what we're going to do in this video. Before we dive in, let's go ahead and tell you some of the threats that we are expecting at this point, just based on the SPC outlook for tomorrow, Thursday, September 21st, which we're going to talk about briefly before we dive in to the details with Friday and Saturday. But the Thursday time frame, there is a slight risk now out for southern Oklahoma and northern Texas, north of the Dallas-Fort Worth Metroplex, places like Denton, Gainesville, toward Ardmore, Oklahoma, Windstar, Casino, in Thackerville. Areas in there are under the gun for a slight risk level 2 out of 5. And there's also a separate area of marginal risk extending across the southern high plains up into the central and northern plains. So southern South Dakota, Nebraska, down into eastern New Mexico, west Texas. All hazards in play. The tornado threat is going to be greatest up in the western Nebraska, southern South Dakota area, with a damaging wind threat and a large hail threat, the greatest threats for that slight risk area along the Red River tomorrow. And then we get into the main show on day 3, which is Friday, September 22nd, where they have now outlined a slight risk level 2 out of 5 for southern South Dakota, central Nebraska into northern Kansas. Again, the day 3 outlook does not have the threats out yet, but we're looking at a potential all hazards threat and would not be surprised to see this upgraded at some point in the future. Friday looks pretty darn interesting as far as severe weather goes. And again, we're going to dive into the differences and similarities among the models for Friday. And then into Saturday, day 4, which is September 23rd, there is a 15% slight risk area out from Iowa down into eastern Kansas, western Missouri, and northeast Oklahoma. We're going to dive into Saturday's threat as well, which also could be an all hazards risk. So without further ado, let's go ahead and show you what is going on currently in the atmosphere. Here is the 500 millibar map from the current SPC mesoanalysis. And there's a few features we can talk about here. Across the southern plains into the southeast, we have a little shortwave trough there embedded within the mostly zonal or east-west flow across the southern portion of the country. That helped initiate the severe weather threat yesterday, September 19th, across western Oklahoma and northwest Texas. A few hail-producing supercells there. But then we have this trough that is back out to the east, and we actually see two different trough axes across the western half of the country. We have this smaller one down here across Southern California into the Pacific Ocean, and then we have one here across the Pacific Northwest. This is our main trough axis up here, this one to the north, and these two are going to combine into one big trough that ejects into the plains come basically Friday and Saturday. Thursday, we're going to be a little bit lagging behind as far as the timing of the trough. We'll go into that here in a second. But Friday and Saturday, these two troughs are going to combine and eject as one across the central plains and then eventually into the Midwest, helping to initiate our rounds of severe weather over the coming days. So it's going to be, unlike these last few events, especially yesterday's event, not going to be your little shortwave, subtle flow, subtle perturbation in the flow. It's going to be a large, deep digging trough that we've seen, we often see in the late springtime with our big tornado events here in the central and southern plains. So that is why this event could be possibly, and again, I'm going to emphasize could be, more significant than some of our previous events here that we've seen over the summer because of the degree of this trough. Now, the one thing that may at least temper the overall amplitude of this trough as it digs in is this ridge feature that is centered across western Mexico into west Texas. Ridge of high pressure centered here, and that is going to amplify slightly as we go into the next few days, and that's going to be a stubborn ridge of high pressure. So this trough is going to dig down, but it's not going to be able to suppress this ridge all the way. So it's going to have to go up and over the ridge. And as such, it may not be, a super deep digging trough down into Mexico. It's going to be thwarted, at least its amplification will be thwarted somewhat by this ridge. Still going to be a very potent trough, and you'll see this as we go and look at some model data of how this trough will progress. But this ridge is going to be stubborn, and that's why the threat for now is focused more in the central plains into the Midwest over especially Friday and Saturday. Now, because we haven't had any significant troughs or significant strong flow aloft traverse the Rockies in the past couple days, including yesterday's event, We haven't seen a robust surface response yet, although as this trough begins to deepen and merge into one here across the west coast, goes up and over that ridge here across Mexico, that is going to allow for lead cyclogenesis probably somewhere in this vicinity here, eastern Wyoming, western Nebraska, western South Dakota. That's where the strongest flow aloft will be pointed, will be traversing the Rockies. So surface flow development is likely probably starting sometime tomorrow. We will start to see at least the eastern fringes of this trough beginning to impact the central high plains here. So we should have enough of a process of lead cyclogenesis tomorrow to develop some weak surface low probably in this vicinity here. Again, eastern Wyoming, western South Dakota, western Nebraska, somewhere in that vicinity. And of course, as that trough, as the main trough aloft moves through, we'll continue to get that cyclogenesis process, and that surface low will strengthen up in this corridor here, Nebraska, South Dakota, into the Midwest for Friday and Saturday. As far as how our surface moisture looks at this point, we do have at least patchy 60s dew points all the way up into the Great Lakes region, with a broad swath of low to mid 60s dew points here extending all the way down into South Texas. We had some 70s dew points down in here yesterday. It looks like those have diminished somewhat, but at least we do have moisture already somewhat in place, so it's not going to take a whole lot to get this moisture up into the high plains for tomorrow's threat and eventually for Friday and Saturday. Again, once we have that surface low developing somewhere in here, those winds at the surface will back and strengthen, helping to really pump this moisture up into the central and northern plains. And eventually into the Midwest for Friday and Saturday. So because we already have this antecedent moisture in place, it's not like we've had a strong cold front push through and shunt all that moisture back into the Gulf. We already have moisture in place, so it's not going to take much to get this moisture up into the regions of interest for the next few days, and therefore we're not talking about a question of moisture return like we probably will over the next couple of months when we have these strong cold fronts push through, shunt the moisture down to the south. Then it takes a little bit extra oomph, if you will, and a few more days to get that moisture back into the area of interest. Not the case with this one. We should have strong surface cyclogenesis up here, helping to strengthen those winds at the surface and continue that moisture advection into the areas of interest. All right, before we dive into the Friday and Saturday comparison and contrasting of the models, let's talk about tomorrow briefly. Thursday, September 21st, again, marginal risk across the high plains with a slight risk here across the Red River Valley in Oklahoma and Texas. So we're just going to use the NAM for this one, just going to briefly go over what may occur tomorrow and give you some of the hazards to expect for tomorrow's event, and then we'll get really into the nitty-gritty with Friday and Saturday. So here is the NAM model initialization, 12Z NAM from this morning. You see it's initialized that trough over the northwest, trough off the southern coast of California, and that ridge here across western Mexico. A little bit of enhanced flow aloft associated on the backside of that shortwave, moving atop that ridge across the southern plains. And as you see, as we go forward in time today into tomorrow, those two troughs in the west begin to merge as one. That one to the south gets kind of absorbed in the flow here going into Thursday morning. And really it serves perhaps to act as a little bit of a shortwave here ahead of the main trough, whose axis is still well back here across the Intermountain West. You see the flow with this main trough here still relegated to the backside of that trough, meaning it's still undergoing its maturing phase. But nonetheless, we still should see this secondary trough here down to the south merge into one. You see this belt of strong flow impinging into the central and southern high plains by tomorrow afternoon into the evening. We also see a little bit of a shortwave possibly out here across North Texas moving atop that ridge, which is centered somewhere down here in western Mexico. That a little shortwave moving into the southern Oklahoma and North Texas vicinity, and that should be just enough, and its associated enhanced flow aloft to initiate those storms tomorrow afternoon across that slight risk area near the Red River in Oklahoma and Texas. A little bit of enhanced flow, 40 to 50 knots here at 500 millibars, helping to initiate those storms and strengthen deep layer shear, especially in the upper portions of the atmosphere for tomorrow. So let's look down at the surface. Surface response is going to be interesting with this. It's going to be somewhat delayed once again because we don't have that trough axis, the main trough axis, ejecting into the plains until probably sometime on Friday. So the response on Thursday should remain at least somewhat muted, maybe very weak, broad surface cyclogenesis here over Colorado into Wyoming tomorrow afternoon, helping to initiate that upslope flow, easterly flow at the surface across northeast Colorado into eastern Wyoming, western Nebraska, to allow for some extra uplift and the initiation of widely scattered to isolated storms tomorrow across this region. Down farther to the south, we see a little bit of strengthening of that flow, given that this surface cyclone is somewhat broad at this point. So we should have some impact from that in the southern high plains, eastern New Mexico, western Texas, and then across the southern plains, Oklahoma and Texas. Not much to speak of there. Perhaps some type of convectively enhanced signal there. Not sure what that little closed contour is, but we'll take a look at the dew points here nonetheless. And you see the NAM forecasting or initializing with broad 60s dew points here from South Texas into the Midwest. Perhaps slightly underdone, although at this point we're looking at early afternoon today, so it does have some 60s dew points up here in the Great Lakes region, which we are seeing as observed with the latest surface analysis, which is not shown. Just took a peek at that. We do have 60s all the way up here in the Great Lakes region, so not too bad with the moisture here. And you see that moisture just kind of sits there and starts inching its way to the west tomorrow. As that surface cyclone starts to take shape, that flow in the low level starts to back a little bit more upslope flow here across the central high plains, and we should get at least upper 50s to low 60s dew points somewhere in western Nebraska, southern South Dakota, perhaps 50s up into eastern Wyoming. So broad area of moisture to work with here across the high plains. Very good-looking moisture here across the southern plains, 70s dew points into eastern Oklahoma. That may be a little high. The NAM does tend to not mix enough, whereas we talked about before the HRRR and some of the CAMs mix too much. The NAM is notorious for not mixing quite enough. Again, mixing is when you have strong surface heating, a little bit of dry air aloft. That gets pulled down to the surface or mixed down to the surface when you have strong surface heating during the day. So probably going to see a little bit of mixing, so I wouldn't be surprised to see dew points a little bit lower than what is progged here, but mid to upper 60s dew points, pretty much a certainty across this area, leading to a juicy atmosphere for storms here across the Red River region. So let's take a couple soundings here up in this upslope flow regime, western Nebraska. We'll take one down here in the southern plains, probably Texas-New Mexico border area. And then we'll take one across the Red River region there in southeast Oklahoma. So again, this is our Nebraska sounding here, and that's not a bad-looking sounding at all. But once again, the trough is going to remain back, so deep layer shear may be a little bit on the weaker side. That doesn't matter a whole lot. If you tuned into our Akron, Colorado case study from back on June 21st, the deep layer shear in Colorado was not all that strong, but you had strong surface vorticity, strong low-level shear developed into the afternoon thanks to a little bit of that upslope flow. Doesn't really matter a whole lot in this part of the world. So we have strong instability building over 2,300 joules per kilogram of mixed layer CAPE by tomorrow late afternoon. Dew points there in the 60s. That might be a little bit high, but still temperature dew point spreads very low. That should favor at least some mix of multicells and a few supercells here. Deep layer shear only about 25 knots, so that is definitely on the low side. But you can see low level shear is on the strong side, over 200 meters squared per second squared of effective storm relative helicity. So any supercell that does form would be able to take advantage of that. Despite somewhat weak deep layer shear, you see there winds aloft only about 10 to 15 knots at most. Across this region, 10 to 20 knots at most across this, especially in the upper levels. But nonetheless, strong veering of those winds with height in the lowest levels could produce a few supercells there, especially given strong low level and deep layer instability. So that's why our tornado threat's going to be strongest up there in western Nebraska. That's where our 2% is right now. Strong low level shear, strong surface vorticity thanks to that upslope flow and some of the terrain interaction out there could foster a tornado or two with any supercell that fires up in that regime. Interestingly, some of the discussions over the past few days have talked about capping across this region, and again, forcing for ascent is going to be fairly weak. That is what is going to be the question mark for tomorrow. Not seeing a bunch of capping here in this sounding, so it looks like we're fully uncapped. But as we talked about before, the forcing for ascent is going to be fairly weak. We see a little bit of that shortwave after that southern trough in the west merges with the main trough. We see a little bit of that as some enhanced flow aloft moving into the central and southern high plains. So not too concerned about storms initiating down here in southern New Mexico or eastern New Mexico, West Texas, but up here it might be a little bit tricky to get storms to go. Not much forcing at all, as the main trough again is lagging well back here, still over the Intermountain West by tomorrow afternoon. So that is the environment for western Nebraska up in the northern portion of that marginal risk. Down to the south, we see a little bit more of that influence of capping closer to that source region for the elevated mixed layer, some steep lapse rates aloft there. A little bit of capping remaining in the south and the southern plains there, but I would think the terrain and the forcing should overcome that for at least that little shortwave down to the south, enhanced flow aloft, should be enough to overcome that for at least isolated storms in the southern regime tomorrow. Stronger deep layer shear for sure. Longer photographs down here in the southern portion of that marginal risk, eastern New Mexico, West Texas. Weaker low-level shear, definitely not as much veering of those low-level winds with height, but would suspect to see any development here in the southern portion of the marginal risk definitely turn into supercells, given strong deep layer shear and decent instability. A little bit of capping to watch, so again, coverage may remain isolated, but the forcing aloft should be a little bit stronger farther to the south, so I would expect at least isolated storms down here in the southern portion of that marginal risk. Here in Oklahoma, the air mass is a little bit juicier there, 86 over 71. Definitely an unstable environment. Those photographs are a little bit on the weird side for sure. Low-level winds are definitely a little bit chaotic. So tornado threat is very close to zero out in the Red River region of southern Oklahoma, northern Texas. But we do have strong deep layer shear for supercells. Although the storm mode may foster a little bit more of a clustered mode. We see most of the strong winds aloft are relegated above 500 millibars. You see very weak flow below that here, below about 600 millibars. So could be a mix, more of a clustered mode here across this region. So mostly a damaging wind threat, but isolated instances of large hail are possible, given decent instability aloft, especially near that freezing level here. As you see those scutees, pretty fat cape near that freezing level there. So large hail, given strong deep layer shear for supercells as well, should be a possibility tomorrow afternoon and evening across the slight risk area. All right, let's dive into the Friday-Saturday time frame. Again, that is when the severe weather threat is expected to be most robust. As we always do with these longer range forecast videos, we're going to look at three different models: the 12Z NAM, the 12Z GFS, and the 12Z Euro hot off the press. So we're going to start out at 500 millibars to see how this western U.S. trough progresses. So we'll start out with the NAM. We'll start our period of interest on 0Z Friday, so 7 p.m. Central Daylight Time on Thursday. You can see the trough centered here across the Pacific Northwest, with most of the flow still relegated to the backside, but starting to come around to the base of that trough, meaning that the trough is undergoing a maturing phase. And as we go through the evening on Thursday into Friday, you see what happens with the trough. As we talked about, that expansive ridge here centered across western Mexico is thwarting that really deep amplification of this trough, but still very much a deep digging trough, with what appears to be a little bit of a shortwave trough out ahead, kind of leading the pack here ahead of the main belt of enhanced flow, which is centered over the Utah vicinity. So a little bit of a shortwave there. That should be enough to initiate convection there across western Nebraska, southern South Dakota on Friday evening. So nice tightly wound trough. We'll see what the GFS has with the progression of this trough. So you see very similar initialization there, continues on into the day on Friday. And while it looks a little bit different, maybe not quite as tightly wound as the NAM, the overall idea is exactly the same. Strong belt of flow here, lagging back across Utah, with a little bit of a shortwave trough here out across Nebraska into South Dakota. The positioning might be just a tad off between the NAM and the GFS, but overall, the idea is pretty much the same between these two models. All right, let's look at the European model now. So once again, looks pretty good as far as how things start off with our period of interest here. And as we go into Friday, basically the same idea. Now this belt of a little bit stronger flow extending out here a little bit farther to the east. Still the main belt of flow back here in the Utah vicinity. Again, a little bit of a shortwave trough out in here, you could say. So overall, the idea among these three models is the same. Positioning might be, and the overall geometry of the trough might be slightly different among the models, with the NAM maybe being slightly more progressive than the other two models. GFS still lagging back a little bit, but overall the idea is exactly the same. We should have the main trough here digging down into the western U.S., a little bit of a shortwave trough out ahead of the main belt of enhanced flow. That should be our main impetus for storm initiation in this environment. All right, let's go down to the surface. We're back to the NAM here, and I'm going to zoom into our Central Plains sector on all three of the models here so that we can see a little bit of a closer look at how the surface pattern might progress. As you'd expect, we should see somewhat stronger surface cyclogenesis going into the Friday period because we've got that stronger flow starting to traverse the Rockies. So here we are. I'm going to back this up to Friday. We'll just start at 0Z Friday, so 7 p.m. Central Daylight Time on Thursday evening. So I'm going to start out with the NAM model here. So the NAM model here, once again, very broad, weak surface cyclone there, centered across the central high plains. Lots of upslope flow here for Thursday evening. That flow, that easterly or southeasterly flow going up the higher terrain here, helping to initiate isolated storms in this area tomorrow afternoon. So as we go into Friday, surface low starts to deepen a little bit, and we get a little bit better closed, a little bit more, still a very broad surface cyclone here. You see just a broad expanse of closed contours here. Perhaps a couple different centers in here. It's a little bit hard to tell where the exact center of the surface low is. We have a closed contour here across southeast Colorado, perhaps one up in here across far western Nebraska. But it's a little bit speculative where the exact center of the surface cyclone is. But nonetheless, we do see those winds at the surface start to back a little bit across Nebraska into southern South Dakota, across Kansas. Very warm temperatures here at the surface as well, especially with southern extent temperatures approaching 90 degrees here in the Texas Panhandle into Oklahoma. A little bit less farther north. And I think this may be a little bit on the cool side. Of course, we've talked about how the NAM tends to be far too cool with surface temperatures a lot of the time. So let's see what the GFS has in store with this surface pattern. So we'll go into Friday here. You see that surface low deepens a little bit, and that's an interesting, a little bit different than what we see on the NAM. We see perhaps a little bit of a circulation right here. You see a little bit of those of the wind barbs here, kind of going in that cyclonic pattern right in here. So there may be a little bit of a surface low here in far southwest Nebraska amid this much broader surface cyclone here. Very cool temperatures out here across southern South Dakota, western Nebraska. So that is interesting. That could represent some cloud cover or precipitation early on, and temperatures really do remain cool up here, which is a little bit surprising. That may shunt the severe weather threat farther south. If you recall, the main slight risk was here, centered across basically southern South Dakota into central and western Nebraska, really barely dipping down into northern Kansas. This may allow the threat, depending on where that shortwave is, to dip down a little bit farther into Kansas. We'll have to dig deeper into this a little bit. But overall, with the surface, possible surface low center down there in southwest Kansas, the NAM could be showing some development or some issues here for southwest Kansas as opposed to farther north. We're just going to have to wait and see how this goes. Again, models have their quirks. Both of these models could be modeling some cloud cover or precipitation, but interesting that the temperatures are very, very cool up here, where the SPC has the main severe weather risk area up in this vicinity here. So we'll have to watch that for sure. Definitely the placement of the overall surface low centers is going to vary here, but overall the idea is the same. Broad surface cyclone with some nice strengthening low level and back to low level flow on both of these models. We'll take a look at some forecast soundings in a second and see how this impacts the overall wind profile. All right, let's see the European model here. Central Plains sector. Here we are Friday evening. As we go through the day on Friday, much of the same. We see a little bit of maybe a slight consolidation of the surface cyclone there across Colorado into Kansas. Once again, cooler temperatures up here to the north. So all three of these models are picking up much cooler temperatures up here. That would not allow for full destabilization up here in this portion of the risk area. That would mean either elevated storms or just kind of rainy, cooler, cloudier weather across this area, and a thwarting of the overall severe threat farther north. But down here to the south, temperatures in the 80s here across southwest Nebraska into northwest Kansas. So that could be something to watch for sure. They may end up extending the severe threat a little bit farther south on future outlooks. As all the models are kind of showing that same thing there. Cooler temperatures in Nebraska and South Dakota, with warmer temperatures to the south, and a little bit of a consolidation of the surface cyclone perhaps farther to the south as well. Looks like perhaps a warm frontal zone right here. Again, we're not sure where the center of the cyclone is, but it looks like a possible warm frontal zone here. You see the wind shift, northerly winds on the north side, and this is the GFS that we're looking at. Northerly winds on the north side of this boundary, southerly winds on the south. So definitely what appears to be a warm front in that zone right there, and that appears to be on all the models. We see a little bit of a pressure tongue there. So a warm front looks like it's going to set up somewhere in the southwest, southern Nebraska to central Nebraska vicinity, down to anywhere to the south, maybe toward the northern Kansas vicinity. We're just going to have to watch and see how that plays out. But that is an interesting depiction on all the models, showing a much cooler boundary layer here, much cooler lower levels of the atmosphere up in Nebraska and South Dakota. let's look at the moisture. We'll look at dew points here for the NAM GFS, and unfortunately the Euro does not have dew points on College of DuPage, so we will bypass that for now. We'll just look at the NAM and GFS. So the GFS is definitely a little bit, is actually much more meager with the moisture here. You see just 50s dew points tomorrow across this region. I tend to think that is a little bit underdone. If we look at our current surface map, we looked at the SPC mesoanalysis, but you see, I'm going to pull up our surface map here. You see 60s dew points are very prevalent here, all the way up into the Midwest, down into the Great Plains and the Southern Plains. So I suspect that we will see much stronger moisture than what the GFS is depicting. As that surface low starts to develop, that moisture will continue to transport northward. So I don't see the GFS solution being all that accurate with as far as moisture goes here. And this is what it's showing. This is what the NAM is showing for tomorrow evening. So we'll start with the NAM. And you see those 60s dew points continue to make their way northward, and we see quite a bit of that 60s dew point layer making it up into even farther, even northern South Dakota there. So this is very interesting. So the dry line seems to set up somewhere in this vicinity here. That is kind of eye-opening there in southwest Kansas. The NAM is showing a pretty decent signal there in southwest Kansas, just looking at the moisture and where the surface low was setting up. Surface low there in southeast Colorado, strong convergence along the dry line there in southwest Kansas. That is very interesting. Also would have a threat up here farther into Nebraska, southwest Nebraska, and you see a little bit wonkiness there in the dew points for western Nebraska up into South Dakota. Again, cooler temperatures up here. That would thwart the overall surface-based severe threat farther to the north. Now let's see the GFS, see how it handles the moisture here. So this is going into Friday. So the dry line positioning is a little bit different here. We see the dry line sets up somewhere a little bit farther to the east than the NAM is showing. The NAM has the dry line a little bit farther back to the west. Overall, again, the idea is the same. Much more meager moisture here. Still adequate for severe weather, but much more meager moisture here. The NAM showing patchy 70s. Again, the NAM tends to overdo dew points a little bit, so something in the mid-60s range would probably be most accurate. And the GFS is showing low 60s, which I think is a little bit on the low side given the current observations at the surface that we just took a look at. So I'm going to pull a few soundings here just to take a look. We're going to go up into South Dakota. We'll take one in kind of the Kansas-Nebraska border region ahead of that little dry line bulge there. And then I'm going to take one in southwest Kansas just to see what's going on. And I'm going to do the same thing for the GFS. GFS not really showing a robust threat up into South Dakota at all, but just based on the moisture and the cool temperatures up there. But I'm going to take a sounding up there anyway. Kansas-Nebraska border region, and we'll take one down there in southwest Kansas as well. So let's take a look at South Dakota. So this is what the NAM is showing for South Dakota. Decent instability, a little bit of capping up here, and you see a very saturated low-level profile. That could very well be indicative of some low-level cloud cover there that sticks around. Surface temperatures only at 64 degrees at 0Z, 7 p.m. Central Daylight Time on Friday evening. So that is either an extreme underdoing of these surface temperatures, or there's some sort of cloud cover. And I tend to believe, given that we have consistency among all three models, that this is quite a bit of low cloud cover, maybe some just rainfall, just normal rainfall that is inhibiting the kinematic or thermodynamic profiles farther to the north. The wind profiles, photographs are a little bit weird, a little bit on the small side up there, a little bit farther removed from the stronger flow aloft. So all in all, the NAM not showing a super robust threat up into South Dakota. This is what the GFS is showing for the same thing, and you see not much instability to speak of, 65-degree surface temperatures and very wonky photographs. So I suspect that the threat may be shifted south here. They may trim off the northern portions of this slight risk, push it to the south a little bit, and extend the southern portions here as we go into the upcoming outlooks. So that was the South Dakota threat. Let's look down now at the Kansas-Nebraska border region, and this is more like it. So you can see robust instability here, over 2,000 joules per kilogram of mixed layer CAPE as progged on the NAM here. A little bit of capping. I do think 74 degrees may be on the low side. We're still removed from that really cool temperature air mass up to the north, so I think this might be a little bit on the cool side. If we can get temperatures in the 80s, that cap shouldn't be a problem. That cap is fairly minimal anyway. Only about minus 100 mixed layer SIN, which is it can easily be eroded, especially if we get temperatures up into the 80s and we have that influence from the shortwave trough aloft. Moisture depth is a little bit on the low side. We can look at that later on in perhaps future videos on each of these days, but the moisture depth is not all that deep, but that shouldn't be too much of an issue. We have robust instability in place, and these photographs looking much better. Closer to that stronger flow aloft, you see 40, 50 plus knots here at 500 millibars with nice curvature there in the low levels of the photograph. Again, this is valid at 7 p.m. Central Daylight Time on Friday. So that is definitely a favorable look for supercells with an all hazards threat, assuming we can get a little bit warmer temperatures than what the NAM is progging here. Let's see what the GFS shows. GFS, again, now the GFS is showing 83 degrees surface temperature there. With a 62 dew point, again, that might be a little bit underdone, so maybe 83 over 65. That is definitely within the threshold, that 20-degree threshold for our temperature dew point spreads for tornadic activity. Instability a little bit less, but still more than adequate, 1,700 joules per kilogram of mixed layer CAPE, and that photograph definitely favorable for all hazards as well. Nice curvature there in the low levels of the photograph with a nice long photograph, 50 plus knots of effective bulk shear as progged on the GFS. So that is the southwest Nebraska, northwest Kansas vicinity. Here's the map just to show you where that is. So somewhere in this vicinity here, Kansas-Nebraska border region, that is where these profiles are looking the best so far for this event. Now, let's look down in southwest Kansas to see what the NAM is showing. That is pretty impressive, I will have to say. The moisture a little bit better down here. Again, 70 might be a little bit on the high side, but moisture a little bit better, instability much better, 3,500 joules per kilogram of mixed layer CAPE. That is a very juicy thermodynamic profile with a very favorable kinematic profile for all hazards here. You see long photographs, 50 plus knots of bulk shear with large looping low-level photographs. A little bit of crosswise vorticity. Again, that's your storm relative wind vector and your shear vector, which is perpendicular and to the left of the photograph. When those are parallel, then you have streamwise vorticity, which is much more favorable for supercells to ingest and produce tornadoes. We have some crosswise vorticity here. Those vectors are perpendicular to each other, but still, excuse me, that does not inhibit tornadogenesis fully in supercells. You can still get tornadoes when you have crosswise vorticity. And with this much low-level shear, 400 plus meters squared per second squared of effective storm relative helicity progged on the NAM here for southwest Kansas, that could definitely be a possibility and why the Storm Prediction Center may end up pushing this to the south. Now, the overall forcing mechanism is going to be the question, because we will be a little bit behind, as progged right now, we will be a little bit behind the main shortwave. I'm going to pull up the shortwave here. So your main shortwave is up in this vicinity here. Southwest Kansas is here. We're a little bit farther removed from any of that activity in the upper levels. So that lends some questions as to whether or not storms will actually fire this far to the south. If we do get a better signal that storms will actually fire, then I do suspect that they will for sure move that down to the south, that risk area down to the south, as we could see a robust severe threat develop there. But again, questions over storm initiation and overall forcing for ascent remain for southwest Kansas. This is the GFS, definitely a favorable looking photograph. Little bit of capping here, 83 over 62, very large differences in the dew points there. We'll have to see how that plays out. I think we'll see somewhere in the middle between the GFS and the NAM, so probably mid 60s or so dew points. Not nearly as much instability. Some drier air aloft, but that photograph definitely looks favorable for an all hazards threat with any supercells that can fire there. Again, questions remain as far as a forcing mechanism down here in southern Kansas, but if a storm can go, that would definitely be a favorable environment for all severe hazards. All right, let's look at Saturday now, and this is when we really start to see the differences in the models. So we'll again start off with the NAM at 500 millibars, and as we go through the day on Saturday, you start to see what happens. That trough really starts to tighten up and really takes on a negative tilt. Really wound up trough there. This is at 0Z Sunday, so 7 p.m. Central Daylight Time Saturday. Very tightly, very compact trough. Exit region of the trough right up here across Iowa into Minnesota. Strongest defluence aloft is up there. We look at 250 millibars real quick. You'll see we have very strong defluence aloft up there, the spreading apart of those wind vectors in the upper levels of the atmosphere. That helps to create a void. Mother Nature doesn't like that void, so it brings the air up from below to fill that void, and that's how we get rising motion for severe storms. And that defluence aloft is very, very strong here in the upper levels associated with this trough. Now, farther to the south, a little bit more complex, we have this ridge, once again, that's situated here over central Mexico. Strong belt of flow atop that ridge, kind of stuck in between this trough up here and the ridge to the south. So that gradient has tightened a little bit, stronger flow aloft. So that's why the threat extends a little bit farther south into Kansas, into Oklahoma, and western Missouri, because we have this belt of stronger flow kind of between the base of that trough and the center of that ridge. So let's see the GFS now. So the GFS does kind of the same thing, just a little bit different pathway that this 500 millibar trough takes. So once again, a very compact trough, quite a negatively tilted trough. You see the axis of the trough looks something like that, with the exit region up in here across the eastern Dakotas into Minnesota. A little bit different positioning. The NAM is definitely farther south with the center of the trough. That is the NAM position. Here is the GFS position. So the GFS, for once in its life, is not the most progressive model. NAM seems to be a little bit more progressive in this case than the GFS. The GFS often tends to be way too progressive with the progression of the troughs. Not in this case. Definitely the GFS, this looks like a very potent setup, even better, even more potent than what the NAM is showing. Very compact trough, textbook negatively tilted trough, textbook exit region of the trough up in here. The question is, do we get moisture up into that region? And we'll take a look at that in a second, how the surface pattern progresses. This is the European model. So the European model does the same thing, but again, this is nowhere near what the other models are showing. Definitely a little bit more disorganized trough, still taking on a very neutral tilt. We do have a shortwave in there up across the eastern South Dakota region into southwest Minnesota. But this is definitely a different look than what the other two models were showing. Tightly wound trough in both the NAM and GFS, just positioning slightly off. A little bit more broad, a little bit more disorganized trough with the European model. So definitely some differences in the models. That's why they have not upgraded this threat to anything greater than just a broad slight risk at this point. We may see upgrades in the future, but definitely the positioning of the trough and the geometry of the trough is different among these models. So we need a little bit more time for those differences to be worked out. Let's go down to the surface. I'm going to zoom in here. Let's zoom into the Midwest sector. That should give us a pretty good... Actually, I'm going to stay at the broad view just so we can make sure we get all of the what's going on at the surface in the picture here. So let's go ahead and look at the surface map for the NAM, GFS, and the European model. So once again, we started off this period with the just kind of a broad surface low across the central high plains. You see there, here's our broad surface low, a couple of different centers in there, possibly one there in southeast Colorado, one maybe up here to the north. But here's what happens as we go into Saturday. So the ejection of that trough takes on a much more negative tilt. As such, we get a much more robust surface response. This is 18Z, so 1 p.m. Saturday. Very, very strong surface response. You start to get that surface low almost occluding very quickly here, where that cold front overtakes the warm front, and you'll have this zone where you have an occluded front right up here in eastern South Dakota into southwest Minnesota. But that is a very, very tight surface low, 21Z. We'll keep it at 21Z here, and you see that low really moves off to the north, meaning indicative that it is occluding very, very quickly here. Occluding surface low means that, again, the cold front's caught up to the warm front, and that tends to signal that you are past the most mature stage of the cyclone. But nonetheless, very strong surface low there. The surface pressure down to about 995 millibars. Let's see what the GFS is showing. So once again, that surface low really takes off. So this is a little bit different of a progression there. You see the NAM really favors that strong surface cyclogenesis. The GFS, not so much. A much more broad surface low up here. You still have a nice center up here in North Dakota with a closed contour around that, but still we maintain this very broad surface cyclone here. And so that is very interesting. Very different surface progression with the surface low on these two models. Let's see what the European model has to say. So we see at least decent surface low development, not nearly as tight as the NAM. So the NAM is definitely an outlier with how the surface pattern progresses. The European model and the GFS model very much in line with each other. A little bit different positioning, of course, but we'll have to see how this plays out. The NAM tends to be very aggressive with how it depicts the low-level response, especially the surface response. So we'll have to see how that takes shape. And this is going to have a lot of modulation on the moisture return. So we would expect with a stronger surface low, that moisture return is going to be more aggressive as well. So once again, we cannot see the moisture on the GFS or on the European model, so we'll look at the NAM and GFS only. So this is the NAM starting Saturday morning, and you see that moisture really starts to feed up into that occluding low. That occluding low is back up in here. Moisture tongue really feeds back into that low. We've seen that before with our cold core type setup, so definitely going to have to watch if we can get this more robust moisture up in here for an arc of supercells along that surface low track. but a very expansive cold front as well. Very moist air mass out ahead of that cold front, 70s plus dew points there, stretching all the way from Iowa down into Oklahoma. Let's see what GFS shows. Wouldn't not expect to be as robust of a surface response. So this is at 0Z Sunday, so 7 p.m. Saturday. Still a very well-defined cold front / dry line there. Very moist air mass, very wide warm sector here with this setup. Not quite as tight of a surface low as well, but still we could see, if robust moisture gets up in here, a tornado threat, an all-hazard threat develop up there with any supercells along the surface low. So let's take a couple soundings here. We'll take one here from the Iowa-Minnesota border, kind of up on that surface low. And then one down to the south here, western Kansas, or eastern Kansas, western Missouri. Just for giggles, we'll take one here, southwest Minnesota on the GFS, and then one down here farther south, eastern Kansas as well. And you see once again that the dry line / cold front is farther back to the west with the GFS. Again, that is quite unusual. Usually the NAM is the least progressive of the models. GFS much more progressive. Not in this case, interestingly enough. All right. So let's pick a new sounding here. This is the southwest Minnesota. So let's take one here on the NAM. We'll go back to 21Z, as we're getting a bunch of convection here being modeled. So this is a little bit better. So you can see that the kinematics are off the charts here, right on the surface low. We are very close, very compact upper level trough, strong defluence loft, strong shear. Strong deep layer shear, 40 plus knots of deep layer shear, but that is a strongly veering wind profile in the low levels with height. Instability on the lower side, again, this is the NAM, 66 degrees might be on the cool side, but decent amount of instability, so we can get a little bit fatter instability there in the low levels. This would be a classic all-hazard environment, including tornadoes up there on the surface low, 1,700 joules per kilogram of mixed layer cape, 600 meters square per second squared of effective storm felicity. If you can get robust updrafts in that environment, that would certainly be a tornado threat. Supercells with a tornado threat would be prevalent up there. Possibly a strong tornado. Again, this is all conditional, and this is just the NAM model. Farther to the south, actually, let's go to the GFS, what the GFS is showing for that area. So the GFS, much less favorable of a look here. This is for, let me just make sure this is Minnesota, and you can see why we are why it's good to compare different models, especially at this forecasting range, because the GFS looks absolutely nothing like what the NAM is showing. NAM is showing a significant tornado type setup. The GFS is not showing that at all. Much less deep layer shear with a little bit of a more muted low level response, especially. You can see that hodograph not nearly as favorable in the low levels for that. Instability still decent, 1,400 joules per kilogram mixed layer cape. That is more than adequate, but again, the wind profile is much different than what the NAM is showing at this point. So we'll have to wait and see how things progress. If the NAM solution comes to fruition, that could be a significant severe weather event up there near the surface low in Iowa and Minnesota. But right now, that is not the case. That is probably an outlier, and the GFS definitely on the opposite end of the spectrum. Down in Kansas and Missouri, here is, you see a lot more instability here, 3,000 plus joules per kilogram of mixed layer cape. Low levels, shear not all that strong, at least in directional shear. You don't see a ton of that veering of the low level wind profile with height. Effective shear only 18 knots. We are farther removed from the trough aloft. Still have some of that flow aloft helping us out, but the deep layer shear not nearly as strong. So maybe a mix of multicells and supercells down here along the cold front. This is on the GFS. So you see what is happening here. It kind of flip-flopped here. The GFS is showing a much more robust threat for farther south along the cold front / dry line. Lots of instability, 2,400 joules per kilogram mixed layer cape. Much more favorable looking veering wind profile in the low levels with height, and a much stronger deep layer shear profile for supercells on the GFS, with the southern target down here in eastern Kansas and western Missouri. So you can see a lot of differences on the models so far. That is why we're that precludes making any specific judgments on specific threats, specific target areas for especially Saturday. Friday, we got a pretty good handle on, still some differences, but the Friday idea is pretty good. But Saturday, definitely there is quite a bit of discrepancy that needs to be worked out before we put in a more refined risk area. So that's going to do it for this video. It's just kind of an overview of each of these days. I will be back with additional forecast videos as these days approach. specifically Friday. That looks to be the most robust day for now. Saturday still up in the air. But once again, we have for tomorrow, Thursday, September 21st, a marginal risk from the northern and central plains down into the southern high plains, and a slight risk along the Red River Valley in southern Oklahoma, northern Texas. Again, with that slight risk, mostly damaging winds and large hail, while an all-hazards threat is possible within that marginal risk area, especially in western Nebraska and southern South Dakota. Then we move on to Friday, which is at a slight risk now. Again, given some of the trends on the models, there could be some trimming done to this slight risk in the upcoming Day 2 outlook, which will come out this evening. We could see a more southward shift. Again, the questions remain whether or not there will be enough forcing for ascent here in southwest Kansas for a robust severe threat. The forcing definitely better farther to the north. And for now, it looks like that border region along the Kansas-Nebraska border is looking the most favorable for severe weather ahead of that shortwave trough with strong low-level and deep layer shear for supercells and strong instability. They may trim this this northern portion as well, given that we saw all the models really have a very cool lower-level profile here. All of the models did, so that could definitely mean a less robust severe threat farther north, and they may trim that slight risk a little bit on the northern end for Friday. All hazards possible on Friday if things come to fruition. That looks like the most certain day so far, with the least amount of model discrepancy. Definitely an all hazards threat could develop, especially with any supercells along that warm frontal zone in southwest Nebraska and northwest Kansas. And then Saturday. Saturday is still up in the air. Once again, we have a slight risk, just a broad 15% area for Iowa down into southeast Nebraska, eastern Kansas, western Missouri, and far northeast Oklahoma. As we saw a lot of model discrepancy here for Saturday, we have anything from a significant severe weather outbreak possible up here across Minnesota and Iowa to basically a non-event, just a run-of-the-mill severe event. So we're going to have to wait and see. The jury is still out with Saturday, but could be an all-hazards threat. We're just going to have to wait and see how those models come together over the next few days to get a better judgment about what is going to happen on Saturday. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.